In this kind of problem, we have, if you look, we have 6.55 grams of V2O5. And so that means we have one amount of a reactant, and we have 10 grams of HCl. So that means we have another amount of a reactant. So we have two amounts of two reactants. And, we have a 1.30 gram of water. And so that means we also have a product, one product. So this is a combination product. So one product amount. So it's not just having one product, you have to actually have an amount of it given. So this adds up to a combination problem. We are going to have to do limiting reactant procedures and also percent yield procedures. So in this case, they tell us that we're making 1.30 grams of water, and they're asking for the theoretical yield of water. So obviously this guy right here can't be our theoretical yield. The 1.30 grams must be our experimental yield, what somebody made in lab. So whatever value they give you for a product, if it's given to you, that means you've gotten it in lab and it's experimental yield. The theoretical yield is always the solution to a stoichiometry problem, which means we probably have to do some stoichiometry. So we're going to look for grams of water, and since we have two reactants, we've got to look for grams of water twice. Because life just kind of sucks that way sometimes. So we're going to start with 6.55 grams of vanadium oxide. Looks like a vanadium 5 oxide. Over 1. And since we're going from grams to grams, we'll once again need 4 complete fractions. We're also going to start with 10 grams of hydrogen chloride. And since we're going from grams to grams, we are also going to need 3 more fractions. Remember that step 1 is to write and balance the equation, which is written and balanced. Step 2 will be to go for the mole. So we're going to use the periodic table to figure out how many grams are in 1 mole of V2O5. And we're going to have to use the periodic table to figure out how many grams are in 1 mole of HCl for the go for the mole step. That's step 2. Then step 3 will be the mole bridge, and step 4 will be the run for the mole, or convert the moles that you have to grams. So let's get started. We need to figure out how many grams you have in 1 mole of V2O5. So I'm going to need the periodic table, and I actually don't have these memorized, so I will have to look it up real quick. So vanadium is 50.94. So I've got 2 of those. So 2 times 50.94 plus 5 times 16 for the oxygen. It's going to be 181.88 grams. So the vanadium oxide is 181.88 grams per 1 mole. So we have 1 mole of V2O5 on top, and we have 181.88 grams in the denominator. And that means that our grams of V2O5 will cancel. Well, then, I might actually erase some of this so that I can write on my... And I just figured out how to use the big eraser. Yay for me. So I can actually see my equation again. Okay, so I am going to go from vanadium oxide, vanadium 5 oxide, to water. So you can see that that is a 3-to-1 ratio. And for every 1 mole of vanadium oxide, vanadium 5 oxide to be precise, I have 3 moles of water. So that means my vanadium 5 oxide will cancel out, and I have done the mole bridge. I have converted magically from V2O5 to 3 moles of water. And the final step is to figure out the grams in 1 mole of water, or to rent from the mole. And so for every 1 mole of water, if you look on the periodic table, that's 2 H's and 1 oxygen. So for every 1 mole of water, that will end up being 18.02. We just keep doing water over and over again, so at some point, I'm just assuming you can remember how to get the 18.02, but it's 2 hydrogens, 2 times 1.01 plus 1 oxygen, which is 16, so it's 18.02. So to get this answer then, we will multiply everything on top, divide by everything on the bottom, so we have 6.55 times 3 times 18.02 divided by 181.88 equals. So my first possible theoretical yield is 1.95 grams of water. So that's a possibility. So now we have to look at what the hydrogen chloride will predict. And once again, for the hydrogen chloride, we need to look up the grams in 1 mole of hydrogen chloride. So that's going to be 1.01 for the hydrogen and 35.45 for the chlorine. So that ends up being 36.46 grams of HCl. And to get that to cancel, we're going to put 1 mole of HCl in the numerator and 36.46 grams of HCl in the denominator. The grams will cancel, and we are back to looking at our chemical equation again. So let's do that. And our chemical equation says that for every 6 moles of HCl, we have 3 moles of water. So we are going to write that in such a way that the HCl's will cancel out. So we have 6 moles of HCl in the denominator, so they will cancel. And 3 moles of water in the numerator. And that will get us to moles of water, but we want grams of water. So we're going to have the same fraction and the final answer for this as the last time, because we're taking both of them to grams of water. So 1 mole of water is 18.02 grams of water. And so we're going to have to take 10 times 3 times 18.02 divided by 36.46 divided by 6. So that looks like a 2.47, which is our other possibility for theoretical yield. Okay, so theoretical yield is the maximum amount you can make, which most of the time you would think would be the largest number. But remember, your theoretical yield is determined by the reactant that's going to run out. And so our theoretical yield in this case is actually going to be the 1.95 grams of water. That is our theoretical yield. And so we'll write that down, and I'll do some erasing. That's going to be our theoretical yield. And let's get some erasing done. Okay, so the next thing, we figured out our theoretical yield. And the one that predicted the theoretical yield was actually the vanadium. So that will be our limiting reactant, because that was the one that predicted the 1.95 grams. The HCl predicted the 2.47. So let's go ahead and make a list of what we know so far and then calculate our percent yield. After I get some of this erased away. Okay, so let's make a list. We know our limiting reactant is going to be the V2O5 because it predicted the 1.47. Our excess reactant is going to be the HCl because it predicted the higher amount. Okay, and then our theoretical yield was the 1.95 grams of water. It was less than the 2.47 of the hydrochloric acid, or hydrogen chloride, actually. Okay, so that leaves us with how to calculate the percent yield. And as we know from a previous video, percent yield is going to be experimental yield divided by theoretical yield times 100. So in this case, we're going to have, this was our experimental yield. This is our theoretical yield. We're going to have 1.30 divided by 1.95 times 100. And let's see what our percent yield will be then. We got 1.30 divided by 1.95, and that looks like 66.7%. So 66.7% was our percent yield. We got 66.7% of the maximum given this situation.